Let's do a famous exercise, and this might come up as an interview question. We're going to try and implement Fibonacci numbers, and Fibonacci numbers are like this. The first number is 0, then the second number is 1. They always start with 0 and 1. Then, this is what happens. We add 0 with 1 to equal the next number. We add 1 with 1 to equal the next number. We add 1 by 2 to get the next number, 2, 3 to add the next number, 5, 8 to add the next number, so on and so forth. As you can see, this grows exponentially. Well, it grows really high, really fast. And this sort of numbering actually shows up in nature a lot. But it's also an interesting problem because these numbers, although at the beginning grow really, really slowly, they become larger and larger and larger. And it becomes a problem that can really hog up the resources. So this is what I want you to do. We're going to create a function, fib, that takes a number, and in here, this number is going to be the index number of the Fibonacci. So for example, if it was the 20th number, it should have this. So if I wanted, let's say, fib 20 here, in that case, I want you to return all these numbers using generator, so that is one by one until we get to this location. Now there's two ways of doing this. We can do it with a list, or we can do it with a generator. And you'll notice that with a generator, it's a lot easier to do than with a list because eventually with a list, you're going to run out of resources. So what I want you to do is to output on here the numbers that you see here all the way until 20. And if you want, you can keep increasing that number and see what happens. And as a bonus, you can try implementing this with a list as well, so it displays in a giant list as well. Pause the video if you want here. Otherwise, I'm going to keep going with the answer. First, what we want to do is say A is going to equal to 0 and B is equal to 1. So A and B are going to be the start of the numbers. Now in here, we're going to use the range generator to loop these number of times that we're going to provide the function. Now in here, first, I want B to now, or A to now equal whatever B was, which is 1, and B to be whatever the next number is. Remember the rule with Fibonacci. We add the first two numbers to get the third number. So we have A, B to get the next number, then A, B to get the next number, and then A, B to get the next number. So the first thing I want to do is to actually yield A and say, hey, just give me whatever A is, and then pause the function until the next part. After that, after the for loop goes to the next part, I'm going to say I want A to equal B, and I want B to equal A plus B. Let's see if that makes sense. I'm saying, hey, return or yield A from this list, so it'll be 0 at first. Then I want you to make A equal to 1 now because we're moving over. And then I want B to equal 1 because A has turned into 1. And then the 1 previously. So B becomes 2. If we look over here, that's what we want. We have A and B here, and then we want to move over just 1, like this. So B should still be 1. So what we might want to do here is to actually not modify A until we are able to do A plus B. So how can we do this? Well, we can simply say, let's say a temporary variable, and this temp is going to hold on to whatever A was when we get here, which is 0. And then we're going to modify a to equal 1. And then b is going to be, instead of a plus b, will be temp, which is 0, plus whatever b was originally, which is 1. I know this can get confusing. You might want to pause here and maybe print and see exactly what's happening. But hopefully our function works now. If now I do something like for x in fib and give it, let's say, 100. And let's just print out the answer. So print x. And I run this. All right, look at that. I get all my Fibonacci numbers. Let's do 20 like we saw in the example. If I click run, I get 4181. So I'm at 19 because remember our count starts at 0. So technically here, if we want, we can do 21 here, click run, and we should get 6765, which is what we get here. Very, very cool. But you can see how the number increases dramatically as we increase to 1,000. Now, if we were to do this in a list, it would look something like this. Let's copy here. Now, fib2 with a list would mean that we have to add a list in here. And instead of yielding, we'll do result.append. And we're going to append whatever the a value is, which is the initial value. And then we're going to do the same thing we've done before. So instead of yield, we're now just appending to this list. And at the end, we just return the list result. Now, if I return this, let's say fib2, and give it 100, and I click run, let's comment out the original one with the generator. Well, we should probably print this, shouldn't we? So let's do print, and click run. All right, that's a massive list. Now, if we were to do 1,000 here, you see that it's taking quite a bit of time. What if we do 10,000? All right, it's definitely taking some time, and you can see over here how hard this is working. You know what? I'm going to stop it and go back to our generator way, and let's do 10,000 here. Let's see how 10,000 looks with the generator. Well, it's still working hard, but I'm not keeping any of this in memory. We're taking it one by one, and I can act upon it, in our case, just printing it one by one. Now, this is a common interview question. It's actually a little bit unnecessarily confusing, I think. But it does demonstrate the power of generators. You might have to watch this video a couple of times, but hopefully by now you're feeling a little bit comfortable with using ranges and how we can improve performance using generators. I'll see you in the next one. Bye-bye.